Hey everybody, how's it going? Let's get this loaded up here. Get this situated. Um, Yo, Mahan, you're alive. Welcome back, dude. He's in here today, claiming his spot. How's it going? You almost done with school? Hey, John Doe, how's it going? Welcome back in, my friend. All right, we are live on the Twitch as well. All right, we should be good to go here. Nice. All right, let's get a little bit of tunes going here.
I switched from due dates to due dates, and it made me go from weeks behind to weeks ahead of my deadlines. You see, I used to.
Oh, all right, you guys. We're here. Feeling good, feeling good. Nice, man. Congrats. Orblish, look who stumbled into the kitchen. Look who decided to show up. This guy. How's it going, everybody? Welcome back into the stream. Feeling good. I like this one. All right. Today, we're getting back to biz. I appreciate everybody for being here. Welcome in. I'm in sunny California. Sunny California, Mr. Orblish. Yeah, I got that boba tea on me, Mahan. Got that boba tea. All right. Welcome in, everybody. I hope everyone's having a wonderful day, and I appreciate everybody for being here. Let's go ahead and get into the content for today. So we're going to start off by getting a couple pages in on our Fluent Python. We're almost at page 100, so we might as well keep going here and grinding. Honestly, if we never stopped, we would probably have been on page like 300, 400 by now. So just goes to show you that stopping really delays you. So we got to keep going on the reading. So we're going to keep going and read a couple pages here. Back to the old Python. Okay, let's read a couple pages here. In line with Python's fail fast philosophy, dict access with the dict index k raises an error when the k or the key is not existing. Pythonistas know that the dict.get key default is an alternative to the dict index k. Yep, we know that. Whenever I guess we're a Pythonista. Whenever a default value is more convenient than handling the key error. However, when you retrieve a mutable value and want to update it, there's a better way. Consider a script in index text. Script to index text, producing a map where each key is a word and the value is a list of positions where that word occurs. As shown in example 3.3. Partial output from example 3.4. Example processing in a Python. Each line shows a word and a list of occurrences coded as pairs. So we have each line is a word and a list of occurrences coded as pairs. To show one case where ticket is not the best way to handle missing keys. Okay. So these are the keys then, okay. Example 3.4 index 0pi uses dict.get to fetch and update a list of word occurrences from the index. A better solution is example 3.5. Import regular expression, import system. We use regular expression to compile the regular expressions all in the whatever the backslash word plus is. With open as this. So you get the list of occurrences for word, or the list is not if not found. And number 1 here. Number 2, append new location to occurrences. So occurrences.append location. Oh, got you. For match and find it or word. Okay, just mapping word. In the key argument, okay, the 3 lines dealing with the occurrences in example 3.4 can be replaced by a single line using the dict.set default. Example 3-5 closer to Alex Martelli's code. Example 3.5 index.py uses dict.set default to fetch and update a list of word occurrences. Update a list of word occurrences from the index in a single line. Oh, gotcha. So index, okay, open this first argument given, the second argument given with this encoding feature as FP for line number and line in the enumerate the FP starting at 1. Match in, so it matches for every match in the find iter on line. Word is equal to match.group every match. Column number match.start plus 1. So get the list of occurrences for word or set it to a blank list if not found. Set default returns the value. Interesting. Automatic handling of missing keys. Sometimes it is convenient to have mappings that return some made-up value when a missing key is searched. There are 2 main approaches to this. One is to use the default dict instead of a plain dict. The other is to upclass a dict to any other mapping type and add a missing method. Both solutions are covered next. Hey Kaden, how's it going? Maybe a little both. Maybe a little both. The default dict, another take on missing keys. A collections.defaultDict instance creates items with a default value on demand. Whenever a missing key is searched using the dict index case syntax, uses default dict to provide another elegant example. Creates items with a default value on demand. Okay, so it will create the missing key. Here's how it works when instantiating a default dict. You provide a callable to the default value whenever get item is passed. For example, given a default dict created as dd equals the default dict on some list, if new key is not in the default dict, the expression default dict new key does the following steps. Calls the list to create a new list, inserts the list into the default dict using the new key as the key, and returns a reference to that list. Gotcha. So here we're opening up this. We're using a default dict though for line and line number and enumerate. Match the word on the line. Group all the words. Match.group word equals the word. Column number. And then location equals line number, column number. Okay, it's just mapping all the words. Create default dict with the list constructor as default factory. If the word is not initially in the list, the default factory is called to produce the missing value. which in this case is an empty list that is assigned to the index word and returned, so the .append location operation always succeeds. If no default factory is provided, the usual key error is raised for missing keys. The default factory of a default dict is only invoked to provide the default values for dunder get item calls and not for the other methods. For example, if the default dict is if in a default dict and the key is missing, the default dict index key will call the default factory to create the default value, but the dd.getK will still return none in K and dd is false. Okay, so the get does not override this. So let's quickly go here and do this. Automatic handling of missing keys. So we'll say collections dot default dict can be used to use as a dict map, but when missing keys are called upon with default dict index K, the default dict will create the key, the line, the map item with the given key. The value is the, what is it called? It said the default factory. The value is the default factory. Whatever object is passed into the default dict on instantiation. See if it likes that. You're absolutely right. Here's a slightly expanded and clarified version. The collections.default dict is a subclass of the built-in dict that overrides the one behavior. When accessing a missing key, it automatically creates an entry using a default factory function instead of raising a key error. Like that. So I'm going to take this default factory then. I'm going to add it here. Right. Cool. So then we'll go here and do the dunder missing method. Underlying the way mappings deal with missing keys is aptly named dunder missing method. This method is not defined in the base dict class, but dict is aware of it. If you subclass dict and provide a missing method, the standard dict.getItem will call it whenever a key is not found instead of raising a key error. Suppose you'd like a mapping where keys are converted to strings when lookup. A concrete use case is a device library for IoT. One such library in pingo.io, no longer under active development, where a programmable board with general purpose I/O pins, a Raspberry Pi or an Arduino, is represented by a board class with a myboard.pins attribute, which is a mapping of physical pin identifiers to pin software objects. The physical pin identifier may be just a number or a string like A0 or P9_12 for consistency. It is desirable that all keys in board dot pins are strings, but it's also convenient looking up a pin by number, as in my Arduino dot pin in pin 13. So that beginners are not tripped when they want to blink the LED on pin 13 of their Arduinos. Example 3.7 shows how such a mapping would work. When searching, oh gosh. At Planet Fitness. When searching for a non-string key, string stir dict 0 converts it to a stir when it's not found. Tests 4 items of retrieval key notation. So example, get the key would be 2 dot get 4 would give us 4, 1, and a. Okay. Example 3 implements a class stir key dict 0 that passes the preceding doc tests. A better way to create a user-defined map type is a subclass collections.userDict instead of a dict, as we will do in the example 3.9. Here we subclass dict just to show that the missing is supported by the built-in dict.getItem method. So in missing key if is instance. So let's go here and give it under missing. Is another Python handling for mechanism for handling missing dictionary keys, but it works differently than the default dict. Missing method is a custom dictionary subclass method in custom dictionary subclasses. If you subclass dict, you can define a missing method that gets called automatically when a key is not found. Yeah. Okay. Without that test for our missing method, we would work okay for any key stir or non-stir whenever stir k produced by an existing key. But if the stir k is not an existing key, we would have an infinite recursion. The last line of the missing, okay, this is just describing this thing here. So we say missing self key. If it's instance key stir, raise key error, right? It's return stir of key, self stir of key in a list. The dunder contains method is also needed for consistent behavior in this example because the operation k in D calls it, but the method inherited from the dict class does not fall back to invoking missing. There is a subtle detail in our implementation of the dunder contains. We do not check for the key in the usual Pythonic way, k in my dict, because stir key in self would recursively call dunder contains. We avoid this by explicitly looking up for key in self.keys. Here in the contains, return key in self.keys or stir key in self.keys. A search like k in my dict.keys is efficient in Python 3 even for large mappings because dict.keys returns a view which is similar to a set, as we'll see in set operations on dict views on page 110. However, remember that the key in the my dict does the same job and is faster because it avoids the attribute lookup to find the .keys method. However, remember that that k in dict does the same job and is faster because it avoids the attribute lookups for the keys method. Yeah, instead of doing the view, you can just say k in dict is even faster. Hey Tim, how's it going? Project tournament. You're making me nervous now, Tim. Do you want an area of software engineering you want to work in or apply for? Web dev, game dev, mobile dev? Have you talked about this before? I don't really know, dude.
Okay, that makes sense Tim SW his background.
Yeah, bioinformatics, probably around there. Data science, yeah. Maybe we could be a data scientist at Meta. Go handle data at their data centers. Make the big bucks. I grew up with someone, not grew up with, but I knew of someone who actually just got a job recently there as a data scientist. So he's probably making big money at old Metter. Welcome everybody for being here. My hair's a little funky. All right.
Tim says my dream job.
Nice, Tim. You got it. I believe in you, Tim. I had a specific reason to use the self.keys in the contains method in example 3.8 to check for unmodified key for the unmodified key. The key in self.keys is necessary for correctness because of stir dict key 0 does not enforce that all keys in the dictionary must be of type stir. Our only goal with this simple example is to make string searching friendlier and not enforce types. User-defined class is derived from the standard library. Mappings may or may not use the missing as a fallback, and their implementations of the get item get or contains as explained in the next section. Inconsistent usage of the missing in the standard library. Consider the following scenarios on how the missing keys lookup are affected. Dict subclass, a subclass of a dict implementing only the missing and no other method. In this case, the missing may be called only on the dict index k, which we will use the get item inherited from the dict. The collection's user dict subclass, likewise a subclass of the user dict implementing only under missing and no other method. The get method inherited from user dict calls the get item. This means missing may be called to handle lookups with dict k and dict.get k. abc.mapping subclass with the simplest possible get item, a minimal subclass of abc.mappings implementing missing and the required abstract methods, including an implementation of the get item that does not call missing. The missing method is never triggered in this class.
Not going to like an elite CS school, but still has a solid program.
abc.mapping subclass with the get item calling string missing. Get item calling missing. A minimal subclass of abc.mapping implementing a missing and the required abstract methods, including an implementation of the get item that calls missing. The missing method is triggered in this class for missing key lookups made with the dict key, dict.get, and key in dict. See missing.pot, an example code repository for demonstrations for scenarios described here. The 4 scenarios just described assume a minimal implementations if your subclass implements the get item, get, and under contains. Then you can make those methods use the missing or not depending on your needs. If the point of this section is to show you that you must be careful when subclassing standard library mappings to use the missing because the base class supports different behaviors by default. Don't forget that the behavior of the set default and update is also affected by the key lookup. And finally, depending on the logic of your under missing, you may need to implement several logic in the set item to avoid inconsistent or surprising behavior. We'll see an example of this in subclassing user dict on page 97. So far we have covered the dict and default dict mapping types, but the standard library comes with other mapping implementations which we discuss next. Variations of dict. In this section variations of dict. In this section is an overview of mapping types included in the standard library besides default dict, already covered in default dict, another take on missing keys on page 90.
Tim, any advice?
I'm assuming, hold on. I like the dunder methods. You don't like them, Anand? I guess that's just the Python in me. I'm assuming there are people currently working in CS in this chat. Can you give me some advice? People are saying that internships for summer 2020 are already opening up now. I really want to get one after my freshman year. Any advice on what I can do to increase my chances? I never did internships. I worked as a waiter during summers to get money. But I honestly,
Anand says, Muna, I'm not from the
I don't really
US, so
know.
I don't have a whole lot of idea about how the companies hire over there, but I do have some friends who have started getting their summer internships.
Okay, this is gonna be here. Collections dot ordered dict. Now that the built-in dict also keeps the keys now that the built-in dict also keeps the keys ordered since Python 3.6, the most common reason to use the ordered dict is writing code that is backwards compatible with earlier Python versions. Having said that, Python's documentation lists some remaining differences between the dict and ordered dict, which I quote here, only reordering the items for relevancy in daily use. The equality operation for ordered dict checks for matching order. The pop item method of ordered dict has a different signature. It accepts an optional argument to specify which item is popped.
People would want to work with. Show that you're willing to learn. Eventually someone will be willing to take a chance on you for an internship. Muna says, Anand Misra, do you know what helped them get those internships?
The regular dict was designed to be very good at helpful mappings, tracking, insertion, order was secondary. Order dict was designed to be good at reordering operations, space efficiency, iteration speed, and for the performance of update operations were secondary. Algorithmically, order dict can handle frequent reordering operations better than dict. This makes it suitable for tracking recent access, for example, in LRU cache. Collections.chainmap. Yeah, this is an O'Reilly book. Do you guys like the TTS on, or you want me to turn it off?
Like LinkedIn, Indeed, or are there more specific websites? Magnet says, Muna, well, the recruiting team and recruiter for whichever internships you apply to.
A chain map instance holds a list of mappings that can be searched as one.
Tim says, I applied on LinkedIn, Indeed, handshake.
A chain map instance holds a list of mappings that can be searched as one. The lookup is performed on each input mapping in the order it appears for the constructor call, and succeeds as soon as a key is found in one of those mappings. For example, D equals dict with these mappings. D2 equals dict with these mappings. From collections, import chain map. You chain those two together. You can access them both. The chain map instance does not copy the input mappings but holds references to them. Updates or insertions to the chain map only affect the first input mapping, continuing from the previous example. So if you add a chain to add chain key to equal -1, it adds it onto the first input mapping of D1. Oh, okay. Interesting. That's cool. So, right, it goes chains, dictionaries together as a referenceable, is that how you spell that? Referenceable? Is that even a word? Object, where searching for keys on the chain object will parse through the original dicts it does not copy values into memory. That's interesting. You guys know about this this chain map thing? So then if we go mapping a new key value pair into the chain object will map to the first dictionary passed in on the chain instantiation. That's cool. Because it's not creating memory, so you can quickly reference two dictionaries as one by chain mapping them together, and then iterate through them both just through one object reference. You guys know about that? Here's a slightly cleaned up and expanded version of explain. So chains multiple dictionaries together in a single referenceable view. When accessing a key, chain map searches each dictionary in order from first to last until it finds the key. It does not copy the dictionaries or their values, meaning it's memory efficient and reflects live updates on the original dicts. Writing. Assigning a new key value pair to the chain map only writes to the first dictionary provided. Useful from managing things. Yeah, this is really good. I like this. I might have to use this in a project or something. Change multiple dictionaries together in a single referenceable view. Right. So, internships are typically looking for juniors or rising seniors. You're ahead of the game if you're a freshman. After my freshman and sophomore years, I worked as a camp counselor. Yeah. But in the meantime, this is a great time to work on projects, get a summer job to show you can hold down a job. Yeah, honestly, a lot of people with summer internships as freshmen, I feel like have a lot of like inside connections. Because a lot of freshmen don't really know what they want to do entirely, and even if they want to do CS, they still, a lot of them maybe aren't as so sure about it, or like, you know. Ooh, something's in my keyboard here. Let me get that out of here, or my trackpad. Get out of there. All right, that's all right. Let me go back and chat. Missing some chats here. You guys are chatting it up. Chat. Yeah, Magnet, this is an O'Reilly book. I think I answered that already, sorry. Oh, sorry, lots of chats. Besides the numbers game, working on perfecting your resume with your career center mind. Make it at least 3 killer projects to put on your resume. Be adaptable and keep applying. Don't restrict yourself mentally that you only work on certain tech stack. Always be ready to take up difficult challenges. Do you mean on a website like LinkedIn or Indeed? All my friends are really good communicators, plus they spin up some simple servers and write APIs in hours. It comes up a lot of practice. Keep learning and applying. Unlike LinkedIn and Indeed, which can be flooded with thousands of applications, cold emails are good. Career fairs are also amazing. I'm emphasizing importance during the interview process. Internships are typically looking for juniors or rising seniors. You're ahead of the game if you're judging. Yeah, whatever. Boils down to 1, be good at coding, and 2, be good at communicating. Dunder methods make no sense at times. Never expose these methods unless you're learning or need some really very specific memory management in Python. All right. Success with career fairs or cold emails. Wasn't there like that meme of like OpenAI that was going to schools like 3 years ago to like career fairs looking for programmers and like hiring them as like sophomores or juniors or something, like, or giving them pretty good internship, and people like didn't really want to work for them back then, or like I don't know, didn't know about them or thought it wasn't real. Okay, that's really cool. I didn't. So I'm gonna take this here. Copy image. Paste that there. I'm gonna take this image too. Okay, chain map is useful to implement interpreters for languages with nested scopes where each map represents a scope context for the innermost enclosing scope to the outermost. The chain map objects section of the collections doc has several examples of chain map usage, including this snippet inspired by the basic rules of the variable lookup in Python. Import built-ins PyLookup chain map locals, globals, and var built-ins. Example shows a chain map subclass used to implement an interpreter for a subset of scheme programming languages. Collections.counter is the next one. We'll probably get through this section and then pause on the reading for today. We've read like 10 pages so far. Counter. If you guys haven't subbed yet, please sub to the channel. Appreciate you guys being here. Okay. A mapping that holds an integer count for each key. Updating an existing key adds its count. This can be used to count instances of hashable objects or as a multiset. Discussed later in the section. Counter implements the plus and minus operators to combine tallies, and other useful methods such as the most common in the n, which returns an ordered list of tuples with the n most common items and their counts. See the documentation. Here is a counter used to count letters in words. I feel like you could use this in a lot of in some leak code problems. CT equals collections.counter, count this, and it counts each of the things in it. Dude, could you just, this could like easily solve some leak codes pretty quickly. CT.update with this, and it updates to the count all those strings, each letter of the string. CT most common of 3. Oh, that's so cool, man. This book is, I like this book because it tells there's so many cool things that Python has that you just don't know about. It makes things a lot easier if you know about all these classes and stuff. Let's count. So I'm going to take this here. We'll say here most common returns an ordered list of tuples with the n most common items and their counts. Okay. It is working. Just being weird. Okay. Note that the B and R keys are tied in third place, but the CT.mostcommon3 shows only 3 counts. Oh, because it's caps, right? Shelf.shelf. Shelf.shelf. The shelf module in the standard library provides persistent storage for mapping of string keys in Python objects serialized in the pickle binary format. The curious name of shelf makes sense when you realize that pickle jars are stored on shelves. The shelf.open module function returns a shelf.shelf instance, a simple key value DBM database backend by the DBM module with these characteristics. Of shelf.shelf, subclass is ABC mutable mapping, so it provides the essential methods we expect of a mapping type. In addition to the shelf.shelf provides a few other I/O management methods like sync and close. A shelf instance is a context manager, so you can use it with block to make use a with block to make sure it's closed afterwards, right? Remember, like with open, it's like open as a context manager as well. So you can use with it, or with is the context, so you can use with a with block. Yeah. Keys and values are saved whenever a new value is assigned to a key. The key must be strings. The values must be objects that the pickle modulation can serialize. The document for the shell, DBM, and pickle modules provides more details on and some caveats. Python's pickle is easy to use. Pause. In the simplest cases, but has several drawbacks. Read Ned Batchelder's Pickle's 9 Flaws before adopting any solution involving pickle. In its post, Ned mentions other serialization formats to consider. Order, dict, chain map, counter, and shelf are ready to use, but can also be customized by subclassing. In contrast, user dict is intended only as a base class to be extended. Can you explain shelf.shelf? Yeah, shelf.shelf is a class in Python built-in shelf module, which provides a simple interface for persistent storage of Python objects. You can think of a shelf.shelf object as a persistent dictionary, one that stores its data in a file on disk instead of in memory. Okay, what is a shelf? It's a module used to store Python objects in a file with a dictionary-like interface. It uses pickle for serialization and DBM or similar backend for underlying key value store. Shelf.shelf class. Shelf is the actual class behind the and returned by shelf.open. DB here is a shelf.shelf instance. Keys must be strings. My data as DB and the keys are strings. Values can be any pickleable Python object, so a string or an integer. Shelf.open file name returns an instance of the file name, which is a subclass. Acts like a dict, stores data on disk using pickle. Values must be pickleable. Keys must be strings. Use write back equals true if you're modifying mutable objects in place, but can be slow. Let me know if you want to try a visual example. Hey Focus, thanks for subbing, man. It's already been 40 minutes. Dang, time flies, guys. Okay, we can be done with the reading here. Let's just get a... Can you give me a simple def? Let's just be done with this here then. A dictionary-like object in Python that stores key value pairs on disk so the data persists between and runs program and allows. Okay. Interesting. All right, well, this is where we'll leave off. We'll do a subclassing user dict instead of dict. Okay. If you guys want access to these notes, you can find them on my GitHub. Give the GitHub repo a star. Link down below for my GitHub. under Fluent Python. This is Fluent Python by O'Reilly, the second edition. We are reading it. We're on pretty much page 100 here, on page like 97, 98. Continued, chapter 3. All right. Sweet. All right, let's get caught up on some chats. I'll put back on TTS. Lots of intern stuff you guys are talking about. My friend got a job at Google. Both his interviews were alums. Gotta help out the alums for real. How did he get lucky that both of them were alums? Was it just like a top school that he went to? Just be shameless, man. Just DM people if you should yourself. You're rejecting yourself before you even get the chance to do so. Yeah, I've had quite a few people reach out to me like for like a referral for my like work, like in terms of like scientists, but I was a little bit, I never actually this might be bad. I never really got back because I didn't know them. Like that is something I will say is that I don't know, like it's hard to vouch for somebody, especially if you're gonna put yourself up at your own company to like say, hey, this person I think should come work here. If you really don't know if they're like a hard worker or not, like because then it can negatively look bad on you and like what your judgment looks like. So like if I actually didn't really know the person, like I probably wouldn't refer them, like just out of like a kind of a moral thing and just like also like a you also need to protect yourself and how you also appear in the company and things like that. It is corporate, so you need to be able to walk those lines. So if you don't actually know their work ethic or their skills, like maybe you could give them an interview beforehand, like like as a friend, like a coffee shop interview, and then just randoms, like never heard, like on the East Coast, just found my LinkedIn somehow and shot me DMs. So yeah, I mean, plot on them. Like, good for them for trying, but I just maybe I should have just given them like a personal interview and then maybe given it a shot. But at least, but it's difficult, right? Okay, let's see here. Oh boy.
Tim says, yay, I will give randoms a chance at a referral, only alums.
Yeah, it's just a little different with random. Like you never know. Like, some people, not. It is true. Like, once you get into the corporate world and you see like you work with all types of ages, demographics, backgrounds. Not everyone is as inclined to work hard as you. A lot of people have other like motives and things. Like a lot of people are there just to like literally supply their life outside of work, like whether it be just to, their kids' hobbies and activities. And so if you try to get them to like want to like do new things and like expand and like automate and get new skills, like they're not really for that, because like some of those older crowd, they're kind of just wanting to, and this is not everybody of course, but there are people that just are there for just to like supply a payment for their life and their family and things like that. So not everybody's going to care about like super new innovative stuff. Like at the end of the day, like it is like life too, so it's kind of interesting, right? Okay, let's keep going here. I don't know how fast API to create a ton of custom classes and they do change the rep registry about this a lot. Yeah. How do you learn TS without getting bored? I don't know TS, sorry. Hey Max, how's it going? Okay. What do we want to do today? Well, what do we want to do today? What do we want to do today? There's a singly linked list head you want to delete a node in it. You're given a node to delete. You will not be given access to the first node. Okay, so delete node in a linked list. There's a singly linked list head, and we want to delete a node in it. You're given the node to be deleted. You will not be given access to the first node of the head. Although the values in the linked list are unique, and it's guaranteed that the given node is not the last node in the linked list. Delete the given node. Note that by deleting the node, we do not mean by removing it from memory. We mean the value of the node should not exist in the linked list. The number of nodes in the linked list should decrease by 1. All the values before node should be in the same order. All the values after node should be in the same order. So here, you're given node 5, and you just need to make the linked list go. But you're not given the head. You're only given 5. So how do you access previous then? If you're on a singly linked list and you're given the current node that only has the value and a next, what? What? So you're given node 5 with the next value. Node 5, that's all we know. How do we know what's behind it? It's just... Oh no, not this guy. Delete that crap. Get it out of here. What do you think, Tim? So you're given a single node which only has a reference of the value and the next node. Each value is unique is something they tell us though. All the values in the linked list are unique. And it's guaranteed that your given node is not the last node in the linked list.
Tim says, what the heck is this, bro?
Yeah, what? How do you access the previous node in a singly linked list if you're given a middle node? We have to find a value in memory that points to this node? What? What? Anybody have any ideas without looking it up? Sounds a little funky, huh? Uh-oh. I clicked on the wrong one here.
Tedious says, my best friend, can you prepare Discord page? I want to join you, my friend. Can you send me Discord?
Yeah, it's down below. Linked in the description. Zeta. Thanks for coming in, dude. So you're given a singly linked list and want to delete a node.
Brandon says, what's a node? I'm self-taught past year.
It's in a linked list, so it's just like a object, like a class object that contains a value and a pointer to the next object in the linked list. For the input, you should provide the linked list. You should provide the entire linked list head and the node to be given. Custom testing for the input, you should provide the entire linked list head and the node.
Tedious says, my best friend, can you prepare Discord page? I want to join you. Can you send me Discord page? Brandon says, can you do a regular list?
No, this is a linked list problem. Interesting. Tim, do you have any idea? Code 237. Can we walk through this step by step, no code? Can we walk through step by step with no code the theory behind leak code 237? If I am given a middle node and only have reference to the
Brandon
next.
says, yay, chat GPT. Tim says, boys, we are smoked.
Let's just try to gauge this one so we can just see if we can get a hint here. We're not gonna look at any code though. I only have reference to the next and the current value. How could we ever get access to the previous, being it's a singly linked list? Every node val is unique, so maybe you need to find a node in memory.
Says, I got it.
You got it? Wait. Don't give it away. Okay. You're given a reference to a node in the middle of a singly linked list, not the head. You cannot access the previous node because it's a singly linked list. In a normally synced list, to delete a node, you typically need to know the previous node so you can get next node equals current.next.
Lemery says, yeah, lol, want a hint.
Is it it wants us to like
Brandon
trick.
says, I guess array.
It wants us to like, it's saying to like trick the linked list. So it's saying to like, because it's gonna start from head. So if we say if wait, so okay, hold on, Tim. So we can go forward, right? So but if, and then it's gonna test here. So if
Tedious says, sorry, I'm sent wrong. Please, can you send me Discord page I to join you?
delete node given self in node. Is self is to node self.next is equal to node.next. Okay, hold on. So we need to access, it's going to give a head, right? Pause. It's going to give, you're given a head in the testing here constraints. Entire linked list head in the node to be given node. Node should not be the last node. So then if, is it self? On delete node. We're calling delete node on an object within some class solution. So type node, list node. If it's linked in the description, Theta, dude. It's in the description, man. So we say like, you're already given the node to delete. You're inside the node that needs to be deleted, so there's no need to loop through.
Lemery says I don't use Python, but my understanding is that node is the node you are supposed to delete.
Yeah. I can't remove myself from memory or rewire the previous node's pointer, but I can change who I appear to be, is the quote it gave me, the hint. I can't remove myself from memory or rewire the previous node's pointer.
Tim says this one is easy. Actually, Mike, I solved it in 2 lines. Lemery says yeah, exactly, that's it.
Simply goes this node.
Tim says it's a freshman level problem actually.
So we have the if we create a list node, or we say node dot next. So the type is a list node. Return, don't void, don't return anything. Modify the list in place.
Anirudh says yo yo yo.
Hey, how's it going, dude? Okay, so we say, what if we say like next value equals to node dot next dot
Tim says in order to get rid of 5 we just need to assign 5 to value of 1 and set the
node
next pointer to 9.
next
Anirudh says, Michael
pointer
Demo
is
ideal
equal to
solve
node
DSA
dot
questions
next
on Java.
node dot. So we could just use Python here and say next value next pointer is equal to node dot next.
Anisha says, what do you think of C?
Oh, hold on.
Anirudh says, plus you can use collections in Java to do it quick.
So I say, right, we want to get reference to the next value. So the next value is equal to node.next.value. The next pointer is equal to node.next. We want to save the current node value to equal node dot or next value, and we want to save the next pointer or node dot next equal the next pointer. Damn it. Get reference of the next value pointer. So we say next value is the node next.
Mlemery says close.
So I say
Anirudh says to delete we need to point the previous link to the
next value equals node.next.value. Next pointer equals the node.next. And we assign the node value to the next value. We assign the node next to the next pointer. No, we want to go to the pointer that it's pointing to. There we go. We don't want to assign it to that pointer. We want to assign it to the pointer after. Boom! Let's go. Okay, then we can kind of clean this up a little bit more into another line. So all right, we got it.
Mlemery says GG.
Next value.
5 Ilvia says GG. 5 Ilvia says let's go. Tim says GG.
So can I just save this here? And then just save node.next
Anirudh says
to here. Will that give us the same thing? Yeah, boy.
Tim says you don't need the assignments at line 13 and 14.
Ah, there you go. Now it speeds it up a little bit faster too. Woohoo! Wow, it was literally 2 lines. That's crazy. All right, moving on. These little like funky the ones make you think so. These ones do a tricky little thoughts. Make you think in weird, crazy ways.
This stuff confuses me badly.
What was wrong with that one? No, that one was a little bit tricky to kind of like think about for a second. But once you kind of figure out the hint, it becomes fairly straightforward. We kind of masked what the node looked like. We just replaced it as the next node, so that it was kind of overrode by the next node in line, so that it wouldn't appear when you get called. Your thoughts on the current sentiment of AI replacing software engineers? Ugh, I'm tired of everybody asking that question.
Text.
Honest, are you guys tired of the AI software engineer discussion? Alright, we haven't done this one. Inverted binary tree. Oh god. Oh god. Given the root of a binary tree, it inverts a tree and return its root. Tech with Tim in the chat. Yeah, Tech with Tim's in the chat here. Hey, no sharing. How's it going?
Tim says no, I'm Tim Hardaway.
All right. So we're given the
Tim says,
root
"Oh, Tim
of a
Houdini,
binary
Tim
tree and we want to
Duncan."
invert the tree and return its root. So what we do is we're given this value and we swap its 2 and its 7. And then we continue going.
Devanshu says island problem.
So with this one, let's open up the whiteboard here. Okay, so with this one, right, we have 4, 2, 7, 1, 3,
Tim says island
6,
problem or we walk my.
9. All right. So if we have this, we're given the root node at the start. Well, right off the bat, we want to flip, right? If we go all the way to the bottom and flip, so if we take this and we flip the 2 and the 7, now we have 4, 7, 2, and then on the 7 is the 6, 9 here, and then on the 2 is the 1 and the 3. So now these are our new root values on this recursive step. So we would swap the left and right childs of these values here.
Anirudh says no sharing happens.
So then we would go 4, 7, 2,
Says, I remember doing
9,
this one.
6, 3, 1. And that gives us to this result. So you would just swap left and swap right, if left and if right. Now what's our base case then? If no left and no right. So then what are our cases here? So if you're on a root, or so if you're on a leaf, right, you do nothing. On a single child, right, you swap to other, like child leg, whatever. On double child, you swap childs. Okay, let's try this out. Let's see what we can do here. You guys think we're on the right path? Let's find out. What the heck? What's going on here? Why is it like this? Okay, there we go. All right. So we're going to say swap nodes. Given node 1, node 2. Def swap nodes. So we say or hold on, let's just say this. Let's say, so if, our base case, so if root is none, so the thing is do we want to stop on one past? So if we currently have none, right, then we're going to return, right? If root dot left and root dot right, then we're going to say root dot left, root dot right equals to root dot right, root dot left. Else, if it has one child, if root dot left, root dot right equals to root dot left, none. None equals root. Oh, hold on. So I say root dot right will equal root dot left. Root dot left equals to none. Else, right? Root dot left equals to, well, we always have, this is a root of a binary tree. So in the case of, well, we
says, is he using recursion?
Okay, so now we got to figure out where we want to call our helper functions. So I'll actually say this. So if there's a root dot
says probably should.
Left equals to, hold on, so let's go like this. Let's say this. So left equals to root dot left, right equals to root dot right. We're going to call inverted tree on this to recursively call on the next root. We're going to get access to some, say if left and right, left, right equals right, left. L if elif left right equals to left, left equals to none, else left equals to right, right equals to none. So let's think about this. So if the root is none,
says okay.
If the root is none, return. Right? So if you come down to a root, to a node value that is none, you'll just return back to the previous recursion with no value. Else, we're going to, on this current root, get access to its left and right subtrees. If there is a left and right subtree,
says, why do you need the different control statements? Is
swap them.
Thing?
Left, right, right, left. Elif left, right equals to left, left equals to none. Else left equals to right, right equals to none. I feel like I need to assign right? I need to return reference to the root node though. So let me call crave equals to tree node, or I mean, we don't even need to keep reference, so we can write a helper function, right, given some root value, or given some node, right? Which will contain these here. And we can get access to, so then we can call return root. We can call helper on root and return root. So if I get access to the left subtree and to the right subtree, but do I need to reassign? This is the reference to that object in memory. And if I reassign them, does it still cascade back to the root? That's my question. So we say in just this case of having a left and right node, you just swap the left and right node. So what if I just do this? What if I just say that root dot or node dot left is equal to, or node, actually, so node dot right is equal to this, and node dot left is equal to that recursive call. We call helper on the root and return root. Invert tree. Oh, invert tree. So this is going to be called, we're going to call helper. We're going to call helper here. Dang it. So this is just returning the root in all cases. What does it want us to return? And return its root. Calling helper on the root. If the node is none, return else node right is helper right, node left is helper left.
No says for x in range, 10 billion.
Helper root, return root. So node dot right equals helper node dot left equals helper on node dot right. That will call so if I just say, what if I say left is equal to helper node left, and then I say the left, no, it's the same thing. So if the node is none, we return well, if the node has no children, we don't want to do anything. If the node dot left and node dot right is none, return. And node dot right is none, return, meaning that you're on a leaf and there is no children to swap. None type attribute has no attribute left. Node dot left is none and node dot right is none. None type object has no attribute left, so it got to down, it called recursively down onto a none object. It called here, so it said, okay, this does have children, so we'll go.
No says, you have to be one with the language.
This doesn't have any children. So why does this get called though? Oh, because we need an else statement here. Well, no, because this is a return. Let's just return none. Back up. So if
5 Ilvia says, I remember learning this one after reading about it.
If node is none, return none. We still get the heads, and that's it. So we're not attaching them. Why? Given root, we're passing root into the helper function. So why is our root getting severed here? If node is none, we return none. Meaning that the next node is none, so it points to nothing. So this will return none back to here on calls on leaves for node right and node left.
Mlemery says think of what you return when node is not none.
If node is not none, if node is not none, if the node is not none, we want to return back to the previous iteration. What do we want to return back to it? This value as the previous value's node right. So the node, the call on helper we need to pass the current node that we're on back up, which we are saving here, so it's getting okay. Let's get the whiteboard out here. So we're going.
No says, this is complex.
So if we have 4, 2, 7, okay, we're starting on here. We're saying, okay, is there a left? There is. Is there a right? There is. So let's go ahead and swap those two values. So if node dot left, node dot right, so let's say left equals to helper of root or of node right dot left. Alright, and then the right subtree node dot right. Okay, then we say if left and right root node dot left equals to right node dot right equals to left. If left node dot right equals to node dot left, else node dot left equals to node dot right. Seven seven nine nine nine. Oh shoot. Left subtree, right subtree. If there is a left subtree and a right subtree, then the node dot left becomes the right subtree. And the node dot right becomes the left subtree. If left we say elif here. We don't want to have an if and then save the right as over again. No. Oh, shoot. And we're done at this point, so we want to return node.
Mlemery says I see like 2 or 3 mistakes.
Swap these two.
Lemery says, what is everyone in chat doing?
So we say we're going to get left and right subtrees. Swap subtrees. Node is none. Going to return none. Right, but if left subtree and right subtree on that node swap subtrees, return helper.
5 Ilvia says chilling. Lemery says based.
Return helper left. So let's just return the root right away here. What happens if we call helper return?
Jamie says, are you in college right now?
No, I'm 26. I graduated back in 2022 or 2021. I have a degree in human biology and a minor in chemistry. Hey Sylvia, welcome back in. How's it going? We just return the node right away, and then that'll happen. I wonder, can we just return the node right away, and then but it'll continue to recursively call?
5 Ilvia says nah, I'm a CS student.
Got that one, but not
Lemery
that one.
says plus. No says, knowing what 1 + 1 = 2 helped.
Okay, so we have helper. If node is none, we return none. So call swap, and we return
5
the node.
Ilvia says but yes, I'm
But we need to
teaching
call
myself
helper on
Python
left and right.
currently, and Java. Lemery says cool.
Call recursion.
Lemery says what language do you usually use in uni? Five Ilvia says C++. Lemery says 8.
That's what I deleted. Now I'm back to that being wrong. So I need to call.
5 Ilvia says but mostly what I've heard other uni uses Java or Python. Lemery says I have friend who have studied CS, they usually use Python.
Swap the left instruction. Going to
Jamie says, do you care for hints from the chatter?
Yeah, as long as they don't give anything away, really. So we're swapping subtrees. Root dot left
Sylvia
equals
says
right.
here I remember learning about it in the beginning. I was lost until I learned C++.
Right, left. Right equals root dot right. We only need node here for one. Swap the subtrees, call recursion.
Mlemery says you were lost in Python and managed C++ lol. Ho says actually, most unis start out with Java or C++. They do have courses that explore newer technologies in Python, cloud, etc.
Return.
Mlemery says, Ho okay nice. 5 Ilvia says yeah it broke it into pieces oof how it actually works in memory.
So say right left equals to helper no dot left.
Mlemery says 5 Ilvia that makes sense to a degree. No says, I'm still stuck in Python I'm trying to move
Swap
to
the left
Java.
and right subchildren, invert the left subtree, which used to be the right. Call helper on left. Call helper on right. And return. I think I just did this. Didn't I get maximum recursion depth on this? Oh. Game. Let's go. Oh, not fast enough, though. If no dot left.
Mlemery says GG. Mlemery says let's go.
If no dot right.
5
So now you
Ilvia
only
says
will do it
let's
if
go.
there's a node. You don't have to call it on a none. So that might be a little bit faster. Yes! Now we got the faster one. Oh, let's go! Woo!
No says, there it is.
Let's go. Nice, you guys. Forgot about my boba.
Mlemery says what's that painting in the background lol.
My girlfriend and I, we drew each other one night. This is her drawing of me. I thought it was kind of funny to put it back here. Ooh. All right.
Mlemery says ha ha ha.
All right, we were able to solve that one. Nice. Woo! Can we try crack one more for quick?
No says, this would have taken me 5,000 years.
Given an integer n, return true with the power of 3, otherwise
Ho
return false.
says, it's crazy that I have never used Python, only been using C and SQL for 4 years.
An integer n is a power of 3 if it exists as an integer x such that n is equal to 3 to the power of x.
Jamie says, do cherry picker too.
Power of 3. So given 27 is true because 3 to the power of 3 is 27. So can we use binary search basically to use a log base? Well, no, that's powers 3. Huh. So if we're given an integer n, 27, well, how many values do we need to check to be a power of 3? Right, obviously 3 to the power of 3 is 27, so you only had to check 3 x values. So 3 iterations. So n can be very large though. Given an integer n, return true if it is a power of 3, otherwise return false. Okay, so if we divide that by 3, we obviously get
5 Ilvius says do pre-order
9.
traversal and in-order or post-traversal binary tree, it's so easy.
I think I've already done those ones already. We've solved like 55 problems or so. I'm not sure we can check though. Okay, so right off the bat, if you modulo this by 3, so let me open up my Python here.
5 Ilvius says wow.
Yeah, we've been grinding a couple LeetCode problems a week for the past since January or so. But 50 doesn't really seem like that many, but I guess like if you do one a day for 50 days, that's kind of a lot. Okay, so let's see here. Let me go find up my GitHub, my LeetCode practice. Okay, so if we have this is 326. So if we go 27 modulo by 3, what is that? Let's print 27. I always have to refresh my memory on what the modulo outputs. So 3 to 27 does not, 3 goes into 27 0 times. Give us a 0 back. 0. Which means that when it says 27 modulo 3, that means that there is no remainder afterwards. 3 goes into 27 evenly. Which means that it is a power of 3. Right, because then if I give
Ho says remainder is 0.
-1, you have a remainder of 2. So then if you just have a remainder of 0, is your power of 3 rule true? So let me go like this. Let's just do this. Let's say like 3 the power of, or let's say like, yeah, 3 to the power of, let's say like, or wait. Yeah, let's say like, 14. Let's take this, that there. Remainder 0.
Says print. Hello, world.
Return if n modulo 3 is equal to 0, we're going to return true. It's false. -1 give us 2. Output is null. Oh. Whoops. If n equals 0. If n equals if n equals 0 and n modulo 3 does not equal 0, or boom! Dang it! I got true for 45. So 45 does but it's not a power of 3. So it's not as simple as the 45. Or it's not as simple as just the modulo. Because 45 can I do this? Could I say so obviously modulo doesn't work. 45 gives you output at 0. All of those. Anybody have any ideas? Powers of 3. given n is a power of 3. So you have to take the value and compute all the powers up until n. So if we say
Ho says, on the right track with mod.
alright, sure with mod. So if we get to 0, we know we have it goes in, divides by 3 evenly. But if 45 divided by 3, so let's think here. Let me get my phone for some math. So if 45 divided by 3 gets us to 15, but 1 divided by 3 is a fraction. 45 divided by 3 gives us to 15. Oh. 27, 0. So what can we do about the 45? Our bounds are to the power of 31. 45 divided by 3 would give us to 15. Modulo by 3 would give us to 0.
Lemery says, I mean, you can kinda ask yourself what has to be true for a number.
So then
to
what
be a
about if we
power of
do
3,
45?
and when you have that answer, you kinda know the code already.
So then if we have which was our previous power.
Lemery says you seem to finding one way to do that already, but it's an overcomplicated way.
Let me see this. Let's see this. Let's say every power of 3 so every power of 3, let's go back to our Python here. 3, 6, 3, 1, 3, 9, 27, 243. All divided, and they're all just multiplied by 3. 3. 1 times 3 is that. So if we go need to find the closest power of 3 to that number, or so for a number to be considered a power of 3, it has to be divisible by 3 evenly, and that divisor has to have been a previous power, right? So let's go like this. Let's add a set then. So saying seen is equal to, no, because it's going to, so then if 15 divided by 3, oh, okay, so let's go like this. Continually to divide it by 3 until you go all the way down, so 45.
Lemery says, but also realize there are far more numbers divisible by 3 than there are number which are powers of 3.
Right. If you modulo a number by 3 all the way down, you will hit 1. right? If you don't hit 1, it's not a power of 3. So while n modulo 3 is greater than 1,
Mlemery says plus. Dho says yup, you got it, that's one way of doing it.
so while n modulo 3 is greater than 1, we're going to continually fact scale this down by 3 until we either hit our base case of 1 or so we could do it with recursion, we could do it with the loop. So if it's 1, so then what do we want to stop on? So if we have 45 and we divide by 3, that gives us 15. We divide by 3, that's 5. We divide by 3, that gives us some fraction. So we say, while that floored is greater than is well, that n modulo 3, do we want to floor this down by integer division of, maybe not. So hold on. So we're going to divide greater than 1. We're going to flag is equal to true. Pass. Else. So while modulo, while we floor, we'll continually floor it, we'll say while n is greater than 1, n equals to n divided by floored by 3. If n, or so then we say if n is, so we have 45 divided by 3, 15. Divided by 3 gives us 5. Divided by 3 gives us 1. So then maybe we don't want to do this. We'll say n is here. We say if n ever becomes so then what if we do that one more time divided by 3? So if one third if you ever land on 1, well, n does not equal to 0. If n is equal to 1, return true, else move n down and return false here. Let's freaking go. Oh, slow as hell though. Slow boy over here. So then Now this is cycling it down. So can we do this even faster by just checking for remainders each time? So, because that will reduce the amount of operations that we have to do, basically, right? So on 45, modulo 3 gives us 0.
Sriant says, what project are you doing?
We're working on LeetCode. I've published my michaeldeming.com, my portfolio website, yesterday. I still need to make it responsive for mobile, but we're doing kind of a study session today. LeetCode, and we did reading at the beginning. So then we now need to do this even faster. For 326, I divide by 3 until I hit 1 or 0. So there's a constant time trick to do something in one iteration rather than a loop. Yeah, they're all factors of one another. What's the largest power through this? Think about it. If 3 to the power of x equals to the maximum power, and n is a power of 3, if 3 to the power of x equals to max power, and n is a power of 3, then the max power modulo by n should equal to 0. So if I say 3, so I have 27 here as n. If a number of power is a power, then it must divide evenly into a larger power of 3. That's the largest 3 to the x less than 32-bit site, 32-bit integer. What? The largest power of 3 that still fits inside a 32-bit signed integer. What's the limit of a 32-bit signed int? The maximum for a 32-bit signed int is 2 to the power of 31 minus 1. So could we int start from 0? What's the largest? So you would, right, I said this earlier, is that, so I just didn't know that you have to use this bound constraint, right? Knowing that this is your constraint for a 32-bit integer, unsigned integer, that if it's modulo by this value with no remainder, it's true. Return if so the largest 32-bit that fits inside of this bound is 3 to the power of 19. So max pow is equal to 3 power of 19. See, this is why LeetCode gets stupid, because knowing this little math trick about powers isn't really like, I don't know if it's, you guys think it's like programming relevant. Like it's like doing that loop before, the slower approach was programming relevant because I was looping and using modulo and whatnot. Like this is just a simple little math trick, like where you had to compute the max power within the constraint bound given here. And then you say if max pow modulo by n is equal to 0, return true. Let's return false here, right?
Lemery says math tricks are very relevant in real life to solve performance issues. Ho says, well, an exam from Intro CS class would def ask this kind of question.
So max pow modulo n by n equals 0. So we got a 0 divisioner. So if n is equal to 0, return none. Okay. Right off the jump, if n is equal to 0. On the negative 1, we outputted a true statement because it's still, if n is less than or equal to 0, return false. Also take a max power. Nice. Interesting. So you just had to determine the maximum that could fit within the constraint. Kind of a dumb one. I like ones that actually require you to write some code, not know a math trick. Cool. This one's a power of 2. This is the same exact thing, basically. we'll have to hit this one tomorrow. All right. Sweet, you guys. This was fun. I appreciate you guys being here. We did some reading in Fluent Python, and then we solved the 3 leak code problems today. So good little jump up on our current problem stack that we've got solved here. How many do we have? Let's look. We have here 57 easies, 5 mediums. Not terrible, not bad, not too shabby.
Lemery says, sire.
All right. Thank you guys for being here.
Actually, there is an
I
interesting
appreciate you guys for
section
being here, and I'll see you guys later. I'll talk to you guys later. Have a great one. I'll see you tomorrow. Have a good one.